bigger than Yellowstone, buried beneath the sea, and almost unknown to the world. This is Apolaki, the largest caldera ever discovered. Its discovery was nearly by chance. In 2019, marine geologist Dr. Jenny Ann Barreto was carefully analyzing seafloor maps of Benham Rise, a submerged plateau off the eastern coast of the Philippines, when something unexpected caught her eye. There, carved into the ocean floor, was a massive circular feature. It was unlike anything she had ever seen. After careful analysis, she came up with a groundbreaking revelation. What she stumbled upon was a caldera of an ancient supervolcano. For the longest time, Filipinos weren't aware that beside their beautiful islands is an ancient supervolcano. This caldera would later be called Apolaki, or Giant Lord in Filipino, a name fitting due to its gigantic size. This massive caldera stretches an astonishing 150,000 meters. To get a better picture of it, this caldera is nearly the entire length of the Gambia, one of Africa's smallest and narrowest nations. It's estimated to be about 3,000 to 4,000 meters below sea level at its deepest points. This discovery naturally raises an intriguing question. What if this ancient supervolcano erupted again? Nestled within the volatile Pacific Ring of Fire, the Philippines is no stranger to nature's fury. Battered by earthquakes, volcanic eruptions, and typhoons, it ranks among the most disaster-prone nations on the planet. Could the Apolaki caldera pose yet another threat to the country? To better answer these questions, we'll need to jump back millions of years to its formation. Scientists are still piecing together the story of how this underwater caldera came to life. They believe a mix of volcanic activity and shifting tectonic plates played a key role in its creation. But because the caldera lies deep beneath the ocean, it's difficult to explore directly. But scientists have pieced together some compelling theories. Chief among them is the idea that Apolaki wasn't born from a single cataclysmic blast, but from a relentless chain of colossal eruptions that unfolded over millions of years. About 26 million years ago, the Apolaki volcanic complex started with a deep underground hotspot. This is the area where superhot magma from the Earth's mantle pushed upward through the ocean floor. At first, the eruptions weren't explosive. Instead, lava slowly oozed out and spread across the seafloor. When this lava touched the cold ocean water, it formed strange rounded shapes called pillow lavas. But what began as a quiet, steady rise from the ocean depths erupted into one of the most powerful underwater volcanic events our planet has ever witnessed. The eruptions were so powerful and repeated that they tore the seafloor apart, leaving behind huge ring-shaped cracks known as ring faults. Similar patterns have been found in ancient supervolcanoes in Australia, where multiple volcanoes erupted over time. But with Apolaki, it was different. This destruction came from a single massive volcano that erupted multiple times. It was in the dramatic transition from gentle lava flows to explosive eruptions that the colossal caldera was born. Even after its final huge collapse, the volcano didn't go quite right away. Scientists found signs of resurgent domes, areas where magma tried to rise again, pushing the ground upward. But eventually, the magma cooled, hardened, and the system shut down. Finally, after millions of years of fiery activity, the volcano fell silent. But with all the raw power this ancient supervolcano unleashed, did it wreak havoc on the ancient world? Surprisingly, its impact was far less catastrophic than one might expect, particularly for life near the ocean's surface. Why? Simply because it lies deep underwater. That depth acted like a natural shield. The ash never reached the skies. The toxic gases stayed trapped below. In deep ocean settings, the water absorbs much of the impact. The real victims were the ancient marine creatures living close to the volcano's core. Blasted by searing heat and flooded with corrosive chemicals, their world turned hostile in an instant. If that eruption had taken place in shallower waters, the story might have ended differently. Volcanic collapses in shallow seas have a deadly track record of unleashing massive tsunamis. A powerful example is the 2018 eruption of Anak Krakatoa. Explosive bursts sent molten lava bombs crashing into the sea, setting off a sudden and deadly tsunami. Waves up to 5 meters high slammed into the shores of Indonesia's Sunda Strait, striking with little warning. The result was catastrophic. Over 400 people lost their lives, and thousands more were left injured in the chaos. Not only that, a significant eruption could eject vast amounts of volcanic gases and ash, if shallow enough, into the atmosphere, which in extreme cases might impact global climate. Just take the case when Mount Pinatubo erupted. The eruption discharged an immense 10 billion metric tons of magma, along with nearly 20 million metric tons of sulfur dioxide into the upper atmosphere, forming a vast ash cloud that stretched across regions. This massive injection of sulfur dioxide into the stratosphere had dramatic global consequences. It cooled the Earth's surface by approximately 0.5 degrees centigrade. For several years, weather patterns were disrupted, and the pace of global warming temporarily slowed, as if the planet had been plunged into a brief, volcanic-induced pause. We can say that we're fortunate that the largest caldera ever found lies deep beneath the ocean, but we can't help but think, could this sleeping supervolcano ever awaken? It's a question with a complex answer. Forecasting such activity requires advanced tools, seismic sensors, thermal imaging, and chemical analysis, and we're only beginning to apply these technologies to the depths where this gigantic caldera rests. But if we want to grasp just how catastrophic an eruption could be, we only need to look at its more infamous counterpart, the Yellowstone caldera in the United States. The Yellowstone supervolcano is one of the most studied and closely watched volcanic systems on the planet. Located mainly in Wyoming, with portions stretching into Montana and Idaho, it sits at the heart of Yellowstone National Park, a place famous for its dramatic geothermal activity and natural beauty. Yellowstone's caldera spans roughly 7,200 meters by 5,500 meters. Yellowstone's history is marked by 3 massive eruptions over the past 2.1 million years. The most recent, relatively speaking, was the Lava Creek eruption 640,000 years ago. This produced the current Yellowstone caldera. If Yellowstone were to erupt in our time, the consequences would be nothing short of apocalyptic. It wouldn't just unleash rivers of lava, it could instantly wipe out up to 90,000 lives and bury the land beneath a 10-foot thick layer of searing volcanic ash, stretching more than 1,600 kilometers from the blast zone. Rescue efforts would be paralyzed. Roads would vanish under ashfall, making ground access nearly impossible, while the toxic plume of ash and gas choking the sky would ground aircraft across entire regions. And perhaps the most terrifying possibility? A volcanic winter, what some scientists call a nuclear winter, where sunlight would be blocked, temperatures would plummet, and global agriculture could collapse, plunging not just the US, but the world into darkness, famine, and chaos. The good news? It's not a story we're likely to live through. According to the U.S. Geological Survey, the magma chamber simmering beneath Yellowstone is only about 5 to 15% molten. That means for now, there simply isn't enough molten rock to fuel the kind of eruption that would rewrite history. Apolaki and Yellowstone may be silent for now, posing no immediate danger, but for Filipinos, a far more urgent threat lies closer to home, the big one from the Manila Trench. If you want to know more about this, just click this next video. If you love our story, please subscribe to be part of our community. As always, until the next one.